Hello friends, now we discuss the derivative of higher order form. Means up to previous period we have seen the derivative of the function in the parametric form or only in the first order. Now here we take higher order means the derivative order of the derivative means how many times we can differentiate this. Suppose we take differentiation only one time, so that order of the derivative is first. So higher means we take the derivative is of second order, is of third order. Proceeding in this way, we will find nth order derivative of this. And therefore, in the last topic of this chapter, differentiation, there are first topic gives second order derivative function, and last topic is the nth order derivative function. But how you define this? So here you have to given that y is a function of x, means y is equal to fx. So first differentiation is given by y1, or you may take that is dy by dx. As we take differentiation on both sides with respect to x, we get that value is f dash x, which is called first order derivative. First order derivative. Now, again differentiate this first order derivative with respect to the same variable, that is a variable is x. So we denote this is y2. Meaning of this y2, derivative of dy by dx with respect to x. So we take differentiation of this dy with respect to x means d2y by dx square. d2y by dx square is 2 times derivative of 1. That is 1 times derivative of dy by dx. That can be denoted by f double dash x, and which is called second order derivative of the function fx. Now again differentiate this with respect to x. We get here y3 d by dx of d2y by dx square. Means differentiation of second order with respect to x, that is third order, we get here d cube y by dx cube, which is denoted by f triple dash x, and which is called third order derivative of the given function. Proceeding in this way, we can find yn. Yn is nothing but nth order derivative, that is d by dx of d raised to n minus 1 y by dx raised to n minus 1. As we find derivative of order n minus 1, again that can be differentiated with respect to x. So we get here d raised to n y by dx raised to n, and that is nth order derivative of the function, and that is called nth order derivative of the given function. So we find derivative of the function by their successive differentiation. If that question is asked to find d2y by dx, then only we have to differentiate twice. If given that to find d3y by dx cube, then we can take its thrice differentiation. And if the question is asked to find yn, then you can differentiate the function n times. This topic is inserted in your syllabus nth order derivative up to previous year. That is discarded from syllabus, but now this in new syllabus nth order derivative is submitted, and we take that nth order derivative by taking some common properties of the function. Suppose we have to find derivative of x raised to n, and that derivative of x raised to n up to nth order means yn. So d raised to n minus 1, instead of y take here x raised to n, and dx raised to n minus 1. So differentiate that x raised to n times, means 1 times, 2 times, 3 times. But what is n? We can't know that n is what that number. But we can take successive differentiation by taking common properties from first, second, third derivatives, and by using this we find its nth derivative. So there is room to find derivative of nth order. Now here direct examples are given from exercise. Last exercise of the chapter is 1.5. From this we take examples directly, then you can understand how you differentiate these example questions to find derivative of the function. Very easy topic. From exercise 1.5, there are 4 types of question. Find the second order derivative of the function. Find second order derivative. Second order derivative. Now we take example only as function y is equal to x raised to x. First function is x raised to x. Now this is the last topic of chapter. At this stage, we take that function is from composite function or that function from implicit function or inverse function or simple trigonometric function or that by parametric function. You can decide which type of this function. So here given that x raised to x. So first of all we take that function is 1. Again this is of the type function raised to function. So this can be differentiated by using logarithmic differentiation as the type is fx raised to gx. So first step is taking log on both sides. For this function we take log on both sides. So we get here log y is equal to log of x raised to x. So meaning of this x into log x. So you take differentiation of this. You have to find second order. So first we find first order derivative. So differentiate this with respect to x. Now for left side first we find derivative of this log. What is the derivative of log function? Reciprocal of its number, that is 1 upon y. By using composite function we can take multiplication of that function with the derivative dy by dx. Now for right side x into log x, apply product rule first. X remains as it is, delta of log x 1 upon x. Next log x remains as it is, derivative of x is 1. Now dy by dx is equal to, shift this one to the right side. This x is cancelled. So first term is 1 and second is log x. So here dy by dx is equal to y into 1 plus log x. Now for the example we may take differentiation on both sides with respect to x. At this step or at this step you may take here by application of u into v rule derivative of 1 plus log x, or you may take simplification as dy by dx y into 1 plus log x. After simplification of this here, one of the expression as dy by dx. Again put value of dy by dx from the same thing. So we take here this dy by dx may be equal to x raised to x into 1 plus log x. So you may use any method to differentiate this as we take 1 upon 1 into dy by dx is equal to, from this step last second step 1 plus log x. You may take here again differentiation, but here you can apply u into v rule. And suppose you can take this last step, so here you can apply u into v rule to the right side. You get same answer. So for this we take again differentiation with respect to x. Now here we take u into v rule application. So for this step 1 upon y remains as it is. Differentiation of dy by dx is derivative of dy by dx with respect to x d2y by dx square plus. Now this dy by dx remains as it is, and find derivative of 1 upon y. Derivative of 1 upon y is minus 1 upon y square. See here dy by dx remains as it is. We find derivative of 1 upon y. This y raised to minus 1. Using this formula, minus this y raised to minus 1, minus 1 y raised to minus 2. So that can be simplified minus 1 upon y square. But this is only for power. Now again find derivative of y with respect to x, that is dy by dx. For right side derivative of 1 is 0 and that of derivative of log x is 1 upon x. To find d2y by d square, so we can simplify for this. d2y by dx square. Now, when we take simplification, here one of the y is multiplied. Here 1 upon y square into dy by dx is equal to 1 upon x. To find this value, so we can shift this term to the right side. So we get here that term becomes positive. Shift this term to the right side. 1 upon y square divided by x bracket square plus 1 upon x. Now, therefore, d2y by dx square is equal to this y shifted to the right side. So, y into 1 upon y square divided by dx bracket square plus 1 upon x. For this simplification, we get that value. This y is cancelled for first term. Means 1 upon y divided by dx bracket square plus. Now this y is multiplied with this, means y upon x. So at last we get answer. d2y by dx square is the second order derivative of the function x raised to x. That becomes 1 upon x raised to x. dy by dx its square. From this expression, dy by dx its square means x raised to x into 1 plus log x its square. X raised to x into 1 plus log x its square. From this and plus y upon x. Again, what is y? X raised to x upon x. This is your final answer. But for first step, we may simplify this x raised to x as a square form and this can be divided. So for first step, you may write only x raised to x into 1 plus log x bracket square plus x raised to x upon x. And therefore, we get final answer again for this. Means d2y by dx square is equal to, here simplify this, you get x raised to x 1 plus log x bracket square for first expression. Only one of the term is cancelled out. And here plus x raised to x upon x means x raised to x times 1 plus log x bracket square plus 1 upon x. This is the final answer of the derivative of x raised to x, which is second order derivative. Up to this we find only first order, but for second order we can do this as finding the derivative. Now for parametric function, there is small change to find the derivative. So we take second question for parametric function. When we differentiate parametric function, now at previous step we have seen that the derivative of the function with respect to its parameter, then we get that answer always in terms of parameter or some constant. But when to find second order derivative, at that time we get the function in terms of its parameter, and that can be differentiated with respect to that parameter, then its answer becomes 0. And therefore, we can take differentiation of the function with respect to that variable. So, we take the adjustment for the function. We take here a question from same exercise, but second question. Find d2y by dx square for x is equal to AP square and y is equal to 480. 280 square. Here x is equal to 280 square, y is equal to 480. Again, this is very easy question. Now take x is equal to 280 square and y is equal to 480. A is constant and d is parameter. So we have to find second order derivative, means we find d2y by dx square. For this case, d2y by dx square, where x is given, y is given. So x and y are the function of t, so differentiate x y with respect to t. So derivative of x with respect to t. Again 2 is constant, a is constant, from derivative of t square 2t. Now for second, dy by dt, 4 is constant, a is constant, and derivative of t with respect to t 1. So by using definition of parametric function, we find here dy by dx. That is dy by dt upon dx by dt. Provided that the denominator is never 0. 4at is never 0. So we take here dy by dt is 4a. dx by dt, 2 to the 4 times a into t. So after simplification we get that answer is 1 upon t. So value of dy by dx. Now this is very important result, as value of dy by dx is in terms of t, because that is function of t. Now as we find d2y by dx square, which is the second derivative of dy by dx with respect to x. Now take as derivative of dy by dx with respect to x, but here dy by dx is the constant function 1 upon t that does not include x, and therefore how we differentiate this with respect to x. And for this case, as in parametric function, we take first derivative is in terms of its variable, then we can differentiate with respect to that variable, means d by dt of dy by dx, and adjust this differentiation with respect to the parameter by multiplying reciprocal of dx by dt. As we find dx by dt, then its reciprocal is dt by dx, that can be multiplied. So see here, this in the terms of ratio dt and dt is cancelled out. We take d by dx of dy by dx, that value is 1 upon t. So every time we can take that result for understanding as d by dt of parameter, here dy by dx, and that can be cancelled out by multiplying dt by dx. Suppose here parameter is theta, so d theta by dx. Here parameter is p, then multiply dt by dx. That depends on the type of function. Now, so here d2y by dx square is nothing but d by dt of 1 upon t. So find the derivative of 1 upon t, 1 upon t square. Multiplying dt by dx means 1 upon dx by dt. So that is minus 1 upon t square, multiply 1 upon dx by dt is divide dx by dt. What is the value of dx by dt? dx by dt is 4at. At last we get that answer 1 upon t square multiplied with this t, that is 4at cube, minus 1 upon 4at cube. And this is value of minus 1 upon t square is the derivative of 1 upon t, and multiply dt by dx means divide by dx by dt. So that is 4at multiply t square, you get 4at cube, and therefore final answer means second derivative of y with respect to x is minus 1 upon 4at cube. So you can remember this step for the parametric function. Now we take example on the topic and show that. So again we have to remember that in second order derivative step, many functions that have first derivative is dy by dx is equal to y upon x, means the function having first derivative y upon x, then its second derivative is always 0. So in the previous topic, means derivative of implicit function, we take examples on K method, means symmetric function. So they are all are the functions have first derivative y upon x, and therefore their second derivative gives answer as 0. Now take example as from the shown that topic. If from third question, if sec inverse 7x cube minus 5y2 upon 7x cube plus 5y cube is equal to m. Then show that y2 or d2y by dx square is equal to 0. Then show that y2 equal to 0 means d2y by dx square is equal to 0. Show that type question. Now y is inserted in the inverse number of the inverse function sec. So we take here sec inverse 7x cube minus 5y cube upon 7x cube plus 5y cube is equal to n. This is given to you. Now for simplification we take 7x cube minus 5y cube upon 7x cube plus 5y cube is equal to sec n. Shift this ratio to the right side by inverse trigonometric function. We take m be the angle of secant function. Now again we say that function is some constant. We say that sec value of the angle of the n is constant. So that becomes 7x cube minus 5x cube is equal to, this function is multiplied to the right side means k times 7x cube plus k times 5y cube. Now shift the terms including y to the left side. So we get simplification. If this term is shifted to the left side, so we get here minus 5y cube is the common. Here factor is 1 and that term is shifted so that k becomes negative. But its sign is common, so we take that is positive. Minus 5y cube minus k times 5y cube. So 5y cube with minus sign is common, so k becomes plus. Now here this for the right side we take 7x cube is common. Here k and its term becomes minus to the right side. So for right side we get 7x cube into k minus 1. Now how you simplify this? So for this case try to take y's free function coefficient. So we take here y cube is equal to 7 by minus 5 into k minus 1 upon 1 plus k, or you may write k plus 1. This k minus 1 upon this k plus 1 of 1 plus k, and this minus 5 is shifted to the right side, which can be multiplied with the cube of x. So 7x cube into k minus 1 upon minus 5 times k plus 1. Now call this constant factor the lambda. You can take this is lambda times x cube. For symmetric function, we already found this example on the topic derivative of implicit function. Now what is implied? Lambda is equal to y cube upon x cube. Now here take differentiation on both sides with respect to x. So we get here 3y square dy by dx, lambda is constant, derivative of x cube with respect to x, 3x square, 3 cancel. Therefore we get value of dy by dx is lambda times x square upon y square. But from the result 1, you take value of lambda y cube upon x cube multiplied x square upon y cube. So x square is cancelled here, this x square. Here this is y square, this y square can split this y square. You get an expression for dy by dx in terms of y and x. So that value becomes y upon x. So by using the hint as the function whose first derivative is y upon x, then its second derivative is always 0. So why this derivative is 0? Now we prove this. So take Now here again differentiation with respect to x. Now here apply u upon v rule. For left side, derivative of dy by dx with respect to x, that becomes d2y by dx square. So d2y by dx square will be the derivative to the left side. Now for right side, start from v. By applying quotient rule, x derivative of y with respect to x divided by dx minus, again we take here y and derivative of x with respect to x, that is 1, and whole divided by v square is here we take x square. So putting value of y upon x from given as divided by dx is y upon x, y upon x minus y upon x square. Now this x cancel with this x, y minus y becomes 0 upon x square, and therefore we get d2y by dx square is equal to 0. So remember then the function with first derivative is y upon x, then its second derivative is always 0. If that function is minus y upon x, then never its answer is 0. Only if the function having first derivative is y upon x, then its second derivative always 0. So many questions of this type. Again, there are some questions which are solved in your textbook. You see this question and solve again for this topic. We have our steps of examples are included because find second derivative by adjustment of given function. We take again one example. If x is equal to a sin t minus b cos t and y is equal to a cos t plus b sin t, then show that d2y by dx square is equal to minus of x square plus y square upon y cube. So from this example we see what is the difference of the question which includes first derivative as y upon x or first derivative as x upon y. From previous question we take, if the first derivative is y upon x, then answer is 0. But from this question we take second idea, as the first derivative is instead of y upon x, that is x upon y, then our work is increases and to find the function of this type. Now we take here, again we can write x and y which is given. Now see x and y are the functions of t, so we can take differentiate both with respect to t. So we take directly find derivative of x with respect to t. See here, a is constant, derivative of sin t, cos t, again b is constant and derivative of cos t is minus sin t, this minus and this minus becomes plus. Now again find derivative of y with respect to t. Now here a is constant, derivative of cos t is minus sin t, b is constant, derivative of sin t is cos t. Now by definition of parametric function, dy by dx is equal to dy by dt upon dx by dt. What is dy by dt? Minus a sin t plus b cos t and dx by dt a cos t plus b sin t. Now you observe these two terms, means numerator and denominator. Here denominator is nothing but 1, a cos t plus b sin t, and for numerator we take minus sign is common. If we take minus sign is common, so that becomes a sin t minus b cos t, that is value of x. So after taking minus sign is common, here numerator is x and denominator is y. So we get dy by dx in terms of x and y. This is parametric function. But when we find second order derivative, then our work is integers to find the derivative of second order derivative. But here if we adjust dy by dx in terms of x and y, then our work is very easy to find derivative by using u upon v result. So we take here again differentiation with respect to x. So we take here derivative of minus of x upon y. So d2y by dx square. This minus sign from remains as it is. Now u upon v will always start from denominator. So y remains as it is. Derivative of x is 1 minus x remains as it is. Derivative of denominator means y divided by dx whole divided by v square means y square. Now we take only proper balance. So d2y by dx square is equal to, now this minus as it is, y minus x into what is divided by dx, again that is minus x upon y whole divided by y square. So simplify this y is multiplied to this y and this x is multiplied to this x by taking minus minus plus. So get here y square minus x square whole divided by y and again that divided by y square. So after simplification we get here x minus x becomes positive. So numerator becomes x square plus y square and this y is multiplied to y square. So we get that is y cube. This is value of d2y by dx square and that can be proved here as d2y by dx square is equal to minus of x square plus y square upon y cube. Up to this we see some examples on second order derivative, but last topic depends on the derivative as nth order derivative. So we can solve examples from nth order derivative by taking their successive derivative. So we take the example from your textbook which can be already solved in the textbook as the derivative of sin x. You can solve on page number 58. Only for adjustment we take derivative of sin x. This question is from the nth order derivative that can be never explained in the, this is never asked in question paper because the topic related with the next year means after 12th standard means engineering college syllabus or 10 BSc syllabus. But this topic is newly inserted in your syllabus. So it is simple one question on this to find nth order derivative. So first component we take that function is sin x. For nth order we take here differentiation divided by x, replace that by y1 y2 by d2y by dx square by y2. So we take differentiate with respect to x. Here only remember three steps as find first derivative with the help of first and find second. Take there is some common property or try to adjust common property. After taking third derivative again you take one more condition is common and proceed the relation of second order to third order and third to next, and by using this common property we find derivative up to nth order. We never find y1, y2, y3, y4, y5, y10, y100. Only we find 2 or 3 derivatives and take common conclusion. So from this we take differentiation of this one with respect to x. We get y1 that is divided by x is equal to cos x. So you know the relation between sin x and cos x. Our proper function is only sin x. Means we have to differentiate sin x n times. But here first derivative is cos x, so try to convert that cos into sin by taking its complementary pair. How we write cos x in terms of sin? pi by 2 minus x. Sin pi by 2 minus x is equal to cos x. Now again differentiate. So what you have to get here? Derivative of y1 with respect to x means y2. So that is derivative of sin is again cos pi by 2 minus x, and derivative of this bracket, that is pi by 2 minus x, means minus 1. Derivative of sin is cos pi by 2 minus x, and derivative of pi by 2 minus x is minus 1. So here you take that answer is minus of cos pi by 2 minus x. Again you may take adjustment. Sin pi by 2 plus x, again that is cos x. You can take this adjustment also. Sin pi by 2 plus x is the cos x. So your answer is 1. With the help of this you may use. Now vice versa, when your question is for cos x, you can find here minus sin x. Minus sin x can be replaced as minus sin x can be replaced as cos of pi by 2 minus x. We can take that adjustment from given adjustment of the function, and therefore here in order to make that function is positive, so we may take that value is positive instead of this multiplying minus. You may take that is pi by 2 minus x also, but here every time we can multiply minus 1. Now cos pi by 2 plus x, that can be converted into sin. How we take that? Replace cos by sin and then complementary of this. How you write this function? Sin pi by 2 plus x is sin of pi by 2 plus pi by 2 plus x. We use only that result. Sin pi by 2 plus x is equal to cos x. Again we may use sin pi by 2 minus x is cos x, but only that work is increased as multiplied every time derivative of minus x. So we take positive. Now y2 is equal to sin pi by 2 plus pi by 2 plus x means 2 times pi by 2 plus x. Now take down again differentiation with respect to x. So derivative of y2 with respect to x, y3. Derivative of sin cos 2 by 2 plus x, and derivative of this x is again 1. Now see, you cannot simplify this 2 by 2 means only pi plus x, but we take here common conclusion. When we find derivative of this cos, we get answer in sin. Derivative sin, we get answer in cos. Cos can be adjusted by taking first property for sin pi by 2 plus x as cos x. Now for third order, we get answer in terms of y. So how you adjust again this cos 2 pi by 2 plus x can be adjusted as sin pi by 2 plus 2 pi by 2 plus x. Use same result. Sin pi by 2 plus x is cos x. So suppose this is x. So we take sin pi by 2 plus x. So what is the addition of this? This is 2 times pi by 2, this 1 times pi by 2, that is sin 3 times pi by 2 plus x. This is value of third order derivative of the given function. Proceeding in this way, you take common conclusion as nth order derivative yn. For sin function is sin. In third order derivative, so we get 3 times pi by 2. Second order derivative, we get 2 times sin pi by 2. So for nth order derivative, we get n times pi by 2, and that can be added in the variable x. So nth order derivative of the function y equal to sin x is sin of n pi by 2 plus x. If you take, this is the minus, then at this stage you can multiply minus, again you can multiply minus, and by adjusting property as minus 1 raised to n, means for second order you get negative answer, for third order you get positive answer, and by using rule of negative number with odd power, that answer is negative, and negative number with even power, that answer is positive. You may take that condition also, but in the simple, easily In this way, we find nth order derivative of the given function. 3 or 4 examples are solved in the textbook. According to board rules, 30% example from the solved example from textbook can be asked in the question paper. So, on this topic, possibility of nth order derivative that can be solved example from your textbook. You saw the examples from exercise and try for this. Now here, our whole chapter of derivative is over. In this 12th standard, we take differentiation in 5 exercises, but these are only depends on the formula from 11th standard, and we take only their properties and with the corresponding new topics as composite function, parametric function, inverse function, implicit function, logarithmic differentiation, higher order, and last topic is nth order differentiation. But every time we can use derivative of trigonometric, exponential, algebraic and logarithmic function. So only you learn this 12 or 13 reason and try to solve examples on this chapter. So here our chapter first of paper second is over. So best luck to solve all examples on this chapter. Thanks to all.